Welcome back to the world of quantum computing. In this video lecture, I am going to explain about the inner products. Because in quantum computing, all the mathematical representations for computation will be done with vectors. So it is very essential to understand the vector operations and computation. So what does the inner vector mean? It is a mathematical operation that takes two vectors as input. So our input will be a two vectors and results a scalar value. Okay, you can see the example here. We have two vectors a and b. So the dot represents the multiplication property here. Okay, how we need to find the vector multiplication? The first element in the first vector will be multiplied with the first element in the second vector. Summation second element in the first vector and the second element in the second vector multiplication. This results in 23, which is a scalar value. Okay, now in quantum computing, how we will represent our inner product? Okay, this is the new term, bracket notation. Be familiar with this notation because it is very important in the further lectures. Okay, suppose we are having two vectors u comma v. So in bracket notation, u comma v will be represented in this format, where the first vector is called as row vector and the second vector is called as column vector. Earlier I said it is represented with bracket notation, right? So row vector is called as bra and column vector is called as ket. Okay, next, if two quantum states are orthogonal, then their inner product is 0. That means first we need to find the inner product of two vectors. Let's say we're having vector u comma vector v. If the inner product, I said in quantum we need to represent in bracket notation of to write in inner to find the inner product. So if the inner product is two vectors is 0, then it is an orthogonal. That means the quantum state is orthogonal. Okay, next, Euclidean space. Euclidean space is nothing but in a Euclidean space, a straight line can be drawn between any 2 points, and also parallel lines will never intersect, which means if let's say we're having line A and line B, line A and line B intersects at some point x. Okay, then this is not considered as Euclidean space. You can see here line A and line B are straight lines, but both are not intersecting together. So it is a Euclidean space. For our vectors, for our u comma v vector, how can we find its conjugate? How we will find the conjugate? In suppose if inverse of u and vector v, then the conjugate will be inverse of vector v dot product with vector u. Okay, now we'll understand inverse operation with vectors. Usually if you need to find inverse of let's say 5, how you will write? Either 5 inverse or 1 by 5. Quite simple, right? Similarly, we'll understand how this can be done in bracket notations or quantum vectors, let's say. So here I took vector A and vector B. Okay, vector A have 3 rows and 1 column, and vector B also is having 3 rows and 1 column. So how to write inverse notation? First of all, if you change the vector into its opposite sign, that means let's say vector A is in ket notation. We need to convert into bra notation. This is the inverse notation of vector A. Similarly with B. Okay. Now vector A, first we'll convert both the vectors. We will find the inverse of both the vectors. So if you find the inverse of vector A, how we can write? I said the notation. We need to write in bra notation to find the inverse. Suppose if we are having a vector in bra notation, how we can find the inverse? We need to write it as ket notation. That means, sorry, like this. Okay. Now what will happen in the inverse? The rows will become columns and columns will be written as rows. So here the three rows will be converted in written in a single row, and similarly with vector B, all the three rows will be written in single row. But we are having an imaginary value 4i and I. Since the imaginary value is present in vector, it changes its sign. So only plus 4i is become minus 4i and plus I has become minus I. Now we'll try to find the inverse of vector A dot product vector B. Okay. For this what we need? We need the inverse of A. So we already found the inverse of A. We'll write it here. Now vector B. From question we can directly get this value. Once you write this perfectly in this notation, it is very easy to find the scalar value. Basic calculation: first row, first column, second row, second column, third row, third column. That is how you will calculate the inner product, right? Similar. Then if you solve this, you will get a scalar value. Now, I said earlier, if you need to find a conjugate of any two vectors, the notation it need to satisfy this condition. If this both are same, then it is a conjugate. So before finding a conjugate of dot product, I'll simply write it. What is conjugate? It should be same, but we are having an imaginary root, so the value will be changed. 2 plus I will become minus 2 minus I. Okay, 2 plus I will become minus 2 minus I. But still we are not satisfied with our answer. So what we can do? We can simply verify our answer. How to find the inverse of vector B dot product vector A? Same. Here we found the inverse value, right? Take the inverse value of vector B, multiply with vector A. You will get minus 2 minus I. Hence, we can tell that both the vectors A, vectors B are conjugate. And we also found the inner products of those two vectors. I hope the content is very much interesting. And in next lecture, we will see about the normalization of vectors. Thanks for watching. If you like my videos, do subscribe, like, share, comment. Thank you.